Now, next question. The space between the slits and the screen is completely filled with a block of transparent material, for which the refractive index is 1.6. Assume the refractive index is constant for all wavelengths. And the refractive index is the ratio of the velocity of the light in the vacuum to the velocity of the light in the material. So describe and explain the changes that will take place in Young's fringes. So now we put a material in here. Okay. Let's have a think. So here's our Young's fringes. Your peaks are such where d sine theta equals n lambda. This distance L, of course, is d times the sine of that angle. Sorry, that's not d. This is d. d times the sine of theta here is going to be equal to that distance there. So d sine theta equals n lambda. What is changing? Well, d isn't changing. Theta, I guess, is where we're looking at. So n, the orders, well, they don't change. So we're going to look at the changes in lambda. Does lambda change when you put the material in? Lambda will change. Remember, our velocity is f lambda, but the velocity has changed with the material. So our velocity equals our speed of light divided by the refractive index. So let's be consistent with the question. That's V material equals f lambda. That is our velocity of light, which we of course c, divided by our refractive index. So lambda equals c n over f. Okay, we're going to get notation confusion. Let's change that n to an m. Not too much notation confusion for one day already. Okay, so c, speed of light in a vacuum, we know. Frequency, that's not going to change. You're still going to get the same frequency light coming in there. It's your lambda that's going to change because your velocity has changed. So lambda changes because velocity of light changes. So lambda is now inversely proportional to your refractive index. So if we go back there, and we look at positions of maxima, they're given by sine theta equals m lambda over d. But lambda equals, let's say, lambda 0, what it was, divided by n, because it's proportional to 1 over n. So sine theta equals m lambda 0 over nd. So what's going to happen is that your theta, your sine theta, is going to get smaller. Or your theta gets smaller. So your peaks are going to get shorter together. Peaks become closer. That's what's going to happen. Describe and explain. So I said what's happening. The peaks are going to come close together. Explain, well, it comes down to the fact that lambda is changing. So you get a different lambda in there. You get a smaller wavelength because the light's not going so fast. Therefore, smaller theta.